everyone. My name is Dr. M. Nagaraju, working as Assistant Professor in the Department of CSE, Artificial Intelligence and Machine Learning in Institute of Aeronautical Engineering, Hyderabad. So today we are here to discuss some of the most important definitions and terminologies which are related to our Module 3. So let us try to understand what are the definitions and terminologies we are going to see in this particular session. So first of all, we will try to understand what do you mean by heuristics. Then we will try to see what is the main importance of using these heuristic search techniques. Later on, we will try to see what are the different heuristic search algorithms are there, and we will try to understand how this heuristic function is helpful in implementing these heuristic search algorithms. And by taking one simple example, we will try to understand what is this, how this generate and text algorithm is going to work. And later on, we will try to work on a specific problem called as hill climbing problem, and we will try to understand some of the basic definitions. I mean, there are some most important definitions like what do you mean by global maximum, what do you mean by local maximum, what is ridge, what is plateau, what is shoulder. These kind of words are there. We need to understand these words in order to solve these hill climbing kind of problems. So that kind of things we will try to understand in different regions in hill climbing. And later on, we will try to understand the definitions of this non-monotonic reasoning and statistical reasoning. And at the end, we will try to see the definitions for conventional reasoning systems. So directly, we will try to understand first with the heuristics concept. So what do you mean by heuristics here? So generally, why we use these heuristics? So in the earlier sessions, also we discussed that most of the artificial intelligence problems are related to some such activity. Means a state will be given to us, and we will be asked to find out a path to the desired state. So in that case, our primary duty is we need to identify the path between the two given points, and that too it should be the optimal one. Optimal one in the sense it should be the more we can say shortest path between the given points. Means especially when you are dealing with such kind of things, our primary duty. So I am repeating the statement once again. You see, when it is artificial intelligence problems, most of the problems they are related to the search activity or search task we can say. In that, our primary duty is we need to identify a path between the given points. Here given points is nothing but given states also we can say. One is the initial state and another one is the goal state. So from the initial state to the goal state, we need to find out the path. So in this case, we are having two things. One is you can able to identify the path between the initial state and the goal state, or you can go for the optimal path identification. Means the path which is going to be the shortest one between the initial state and the goal state. So in order to overcome this kind of activity, means in order to solve these kind of activities, definitely we can say that heuristics is going to play a major role. So we need to understand, means whenever we are trying to solve this such kind of problems, we need to understand how this heuristics is going to support us in getting the optimal solution. But we cannot say that whether this heuristic is going to give the optimal solution or not, but we can say that this heuristics is going to help us in order to identify the path between best path we can say. Okay, best path between the initial state and the goal state within the given shorter period of time. So we will try to understand more clearly about this heuristics. So what this heuristics is? So in simple words, we can say that heuristics is a method which is used to improve the efficiency of the search process. In order to improve the efficiency of the search process, we are going to make use of this heuristics. So we can say that if we are not using any kind of heuristics, it means that we are performing some blind search. We are performing some blind search. So in that case, we can say that we can, even though if we are reaching to the goal point, we cannot say that the path whatever we have identified will be the optimal path. And sometimes even what happens, even with before point moving to the goal state, sometimes we may move to the dead end state. So in that case, again, what happens, we need to apply this backtracking mechanism, and we should come back and we should look for the other path. So that's why we are. I am saying in simple words, I am saying that if you are not using any heuristic approaches or any heuristic techniques, if you and you are performing some search activity, that means that it is a blind search process where you cannot guarantee that you are going to find out a best path between the given points. That's why we can say that a heuristic is going to help us in improving the efficiency of the search process. And one drawback, we can say that it is not, means we cannot say that heuristic is going to give you the best solution. Of course, heuristic is going to help us in order to find out the shortest path, or in order to find out the path between the given points. But whether that path given is the best path or not, that we cannot guarantee. We cannot guarantee. So that's why we are saying that heuristics may find the best solution every time, but guarantee. So what it is guaranteeing means, it is guaranteeing the good solution. Means when you are comparing with the traditional search algorithms, we can say that this heuristic approach is going to give you the good solution for us. Okay, so why if it is not giving the best solution, why we are using these heuristics means we are having certain kind of limitations like time complexity and space complexities. So in that case, right, even though if it is not giving the best solution, even sometimes what happens, even good solution is also going to be the good outcome for us. So that's why heuristics, even though if it is not giving the best solution, we are making use of it in order to get at least a good solution in the reasonable period of time. So these are particularly, we can say, useful in solving tough and complex problems. Tough and complex problems where while solving the problems, it may take an infinite period of time. So let us try to understand this statement with an example. For example, think that a traveling salesman problem is there. So if that traveling salesman is given the number of cities to visit every time is 10. So if the traveling salesman want to identify the shortest path between these 10 states, he is going to have some lakhs of possibilities. Means in order to identify which one is the best path or which one is the shortest path, he need to extract, or he need to explore all the possible paths that are available in between these 10 cities. So in that case, what happens, the traveling salesman is going to spend his whole lifetime in order to get which one is the best path or which one is the shortest path. So we can say that traveling salesman problem, identifying the shortest path manually can take even the lifetime. That's why we are saying that the problems which are taking infinite period of time, to those problems we can apply these heuristics. So coming to the heuristic search techniques. So it is itself is telling that heuristics is an approach, or heuristic is a thing which you are making use in order to work with this search process. So when compared with the traditional search algorithms, so already in data structures we have seen different kinds of algorithms like a depth first search. We have also seen breadth first search, and at the same time we have also seen some bidirectional bidirectional search process, these kind of things. So generally we call them as a traditional search algorithms. So when we compare these traditional search algorithms with the heuristic search algorithms, we can say that heuristic search techniques or heuristic search algorithms are far better than the existing one. So till now, what happened? Till now, in the most of the artificial intelligence applications, we have used these traditional search algorithms only, like DFS, BFS, bidirectional, like that. But what happens when the problem complexity is increasing? We cannot you make use of these traditional search methods to solve it. Why? Because they are unable to find out the best solution in the given period of time, and also based upon the space limitations. So we can say, in simple words, we can say that the depth first search, breadth first search, these kind of traditional search algorithms are having certain kind of limitations. What is that? That they are unable to find out the best solution, and also they are going to take lot of time. They are going to take lot of time in order to perform this search activity, and also in the given space limits, they cannot able to get the best solution. So in order to overcome, or in order to handle these kind of limitations, we are concentrating on the new approaches which are called as heuristic search techniques. So we can say that, especially when we talk about these heuristic search techniques, the main important point we need to talk is about the heuristic functions. So what these heuristic functions are going to do? So especially in the heuristic algorithms, heuristic function is going to play an important role. Why? Because the heuristic function itself is going to give us some kind of numerical values, we can say. They are going to give some kind of numerical values which will be helpful for us in order to select a particular path. Let us try to understand this with an example. For example, think that this is your initial state, and this initial state is having two different paths. Either you can move to this particular node state, or you can move to this particular state. But we cannot guarantee that if we move in this particular state, it is going to be the best path, which can lead to the goal state. So in this case, what happens? You are going to get some kind of ambiguity, means some kind of disadvantage, some kind of gap, means which one we need to select. So in these kind of things, what happens if you are implementing the traditional methods, means if you are performing this blind kind of such activities, so what happens, even if you are selecting one particular path, it may not lead to a goal state sometimes, or it may not be the best path. So in that case, what happens, we are going to make use of these heuristic functions. So what this heuristic function will do, it will try to, whenever we apply this heuristic function, it is going to give us some kind of numerical values. So these numerical values you can consider in different ways. Sometimes you can consider these numerical values as a distance. Distance in the sense, for example, if you take here the distance between this node and this particular node, or from initial state to the second state, or the distance between 1 and 3 nodes. And sometimes what happens, even these values you can consider as Euclidean distances also. Not only just the distance, whenever I say it is distance, it is the distance between the initial state and its very immediate state. So if I write some 5 here, means after applying this heuristic function, you got a value of 5. So what does it mean? This 5 is going to talk about the distance between this initial state 1 and the other state 2. Okay, so but when it comes to the Euclidean distance means the distance between the initial state and the goal state. Maybe goal state may be somewhere. Okay, so if you apply the heuristic function, and if you get the Euclidean distance of 10, so what does it mean? Means the distance between the initial state and the goal state is 10. Of course, there will be some adjacent states also, but we are just looking about the distances. Okay, so here whenever you apply this heuristic function, and whatever the values you are getting, that value can be used either as a distance, means it's completely depends upon the application you are using. So it can be a distance, you can consider it as a distance, or you can consider it as an Euclidean distance, or sometimes based upon your applications, and even you can consider them as weights. So in order to overcome, means in order to not just to perform this blind search. Why? Because in blind search we won't guarantee, means we are going to get the best path. So in that case, it's better to use this heuristic function and get some kind of numerical values, and try to make use of these numerical values in order to move to the next state. Okay, so for the simple understanding, we can say if the heuristic function has given the 10 as the distance between this 1 and 3. So what does it mean? If you are looking for the shortest path, you are going to select the path which is having the shortest one. Means here 5 is the shortest one. So simply you are going to ignore this particular path, and you are going to move in this particular direction. So what happens? The heuristic value what we got here from the heuristic function is making us to move from the initial state 1 to initial state 2. So why we have selected this one? Why? Because this is the shortest one when compared with the other. So we need to make use of this heuristic function in this particular manner. Now the question comes is, how far these heuristic search techniques are better? So just now we discussed that when the complexity of the problems is increasing, we cannot make use of this traditional search algorithms. So we are saying that heuristic search algorithms are going to help in that case. But here, how we are going to decide they are the so better one? Heuristic algorithms are so better. So we can say heuristic algorithms are not really intelligent. Why? Because why we are calling it as not intelligent? Because they are not producing us the best solutions. But of course, even though they are not best solutions, but they are the good solutions for us. So they appear to be intelligent because they achieve the better performance when compared with the other traditional search techniques. And at the same time, why these heuristic search techniques are having that much better performance means it is making use of this advantage. What is the advantage of it? Is making use of the feedback advantage. Means from the feedback advantage, it is going to improve its efficiency. So the heuristic algorithms are going to improve its efficiency of searching by taking the advantage of the feedback from the data to direct the search path. Okay, so we can say that by learning approach, these heuristic search algorithms are becoming better and better. So coming to the types of heuristic search algorithms. So we can say that there are two different kinds of heuristic search algorithms. One we can say one among that one, the first one is the uninformed search algorithms, or otherwise we can say it is a brute force algorithms. So the name itself is telling that uninformed. So what it is not informed means you are not going to get any additional information. Additional information means you are not going to get anything about the heuristic values from the problem statement. So in that case, what happens? It will become just a blind process, blind approach of identifying a path between the given points. So because of that one, we are saying that it is an uninformed search process. So in this search algorithms, what is going to happen means the search through the search space we are performing by making use of all the possible candidates for the solution and checking whether each candidate satisfies the problem statement or not. So it is a blind process. No? So in this blind process, we are going to search for all the available paths. So after identifying all the available paths, we are going to come to know that which one is the best one. But it is going to take a lot of time. So the time complexity is also going to come in this particular case. So we cannot say that in order to solve this real-time search problems, uninformed search algorithms are not that much applicable for us. But we can make use of the other kind of search algorithms which are called as informed search algorithms. So what happens? It is not going to be a blind process. Okay, simply we are not going to select any of the path and moving towards the other nodes, other adjacent nodes. But here what we are doing? We are applying some kind of intelligence, we can say. What is that intelligence? Trying to implement some heuristic function, try to get some kind of heuristic value, make use of that value as a distance or as a weight. Then you can follow accordingly. Means which one is the shortest one, that one you can select, and in that particular path we can continue our traversing. So we can say that this informed search algorithms, they are making use of the heuristic functions. So these heuristic functions are going to be specific to the problem. Okay. So apply them to guide through the search space to reduce the amount of time spent in searching. So just now we have seen an example. When there is two paths between the given node, two paths to a one particular node, and which one to be the next node to select, the heuristic function value is going to be helpful for us. So in that case, we can say this is going to reduce the amount of time spent in searching. Why? Because simply directly what is happening, we are moving from one point to another point simply by ignoring the other path. Why we are ignoring means when we compare the heuristic values of these two paths, 5 is the shortest one. So whenever your problem statement is to find out the shortest path between the given points, then what is the use of selecting this particular path? So what is happening here? The heuristic function or the heuristic value is making us to reduce the time taking to perform the search activity. So when we compare the search algorithms, these two search algorithms, we can say that the algorithms which are making use of these heuristic functions is having a lot of advantage when compared with the other one. So for real-time search activities, it's better to select the informed search algorithms to identify the shortest path between the given points. Let's talk a little bit about the heuristic function. So we can say that heuristic functions are used in some approaches to search or to measure. This is very, very important. That's why I said that heuristic function is going to give some kind of numerical value. So this numerical value, we are considering it as sometimes distance or sometimes Euclidean distance or sometimes the weight. So what this heuristic function is going to do, it is an approach, we can say. It is an approach which is going to give some numerical value. So based on that numerical value, we can perform the measuring. So measuring of what? Measuring of the shortest distance between the nodes. So what happens here? This approach is going to help us to perform the search or to measure how far a node in a search tree seems to be from the goal node. So if, in this case, you can consider the Euclidean distance. So in this particular statement, what happened? From a given state or from the current state, what is the distance that is to the goal state? This is your given state, we can say given state, or otherwise if you are in between the search process, it can become a search state to you, current state to you. So what is the distance between your current state and the goal state? So how we are going to get means by doing some kind of measure. What is that measure? It is nothing but some heuristic value. So in this particular case, what happens? It becomes the Euclidean distance. Okay, so we can say that heuristic predicates that compare two nodes in the search tree to see if one is better than the other. Just now we discussed. Okay, so in this case, what is happening? It is going to do some kind of comparison. Means it will help us to perform the comparison that which one is having the shortest path. Okay, so which one is the shortest distance. So based on that, we can move towards the goal state. So what happened whenever we do such kind of comparisons, it is making us to advance towards the goal state. And even of course we can say that even if you are selecting the other path also, you will move to the goal state. But our intention is not just to find out the path. If our intention is only to find out the path, it's better to use only the traditional search algorithms. It's not necessary to go for the heuristic search algorithm. So the main intention of heuristic search algorithm is to identify the best path, or we can say to identify the best good path between the given points. So until and unless you perform this comparison, you will not move towards the goal state. So the heuristic is going to give you some numerical value which will help us in order to measure the distances between the given nodes. So based upon the distances, whenever you are selecting the shortest path, it will definitely make you to move towards the goal state. Let us try to understand one algorithm about this. So this is an algorithm which is called as generate and text algorithm. Generate and test. The name itself is telling, and it is very simple algorithm when compared with the other algorithms. So this algorithm is having only 3 important steps. So the first step is generate a possible solution. Generate a possible solution. So in this case, we cannot say that this solution is our main solution. But anyhow, you are generating a solution. So it can be generating a particular point in the problem space. So we can say that a possible solution in the case, we can say that the change in the state. The change in the state. That's why we are saying that generating a particular point in the problem space and generating a path from the start point. So what happened? For example, if this is your initial state. This is your initial state. So what you have done? You have generated a possible solution. You have generated a possible solution, and this is your possible solution in this case. So what is possible solution is the change in your state. Now this will becomes your current state. Initially you are starting your search process from this particular node, and after making use of this heuristic value, think that you have moved to the other state, which we are calling it as a current state now. So what does it mean? Means we have performed the generation of a possible solution. So once a possible solution is generated, what is our next step? We need to see if this is actually a solution. Why? Because we cannot guarantee that. Means we don't know exactly that this is going to be the goal state. Sometimes it may happen, it may be, or sometimes it may not be. So in that case, what happens? Every time whenever you are generating a possible solution, definitely you have to do the comparison of the newly obtained state, current state, or this is considered as a newly obtained state. So this newly obtained state, you need to compare it with the goal state. Why? Because sometimes what happens, you may be at the adjacent to the goal state. So in that case, what happens? The possibility is your newly coming state is going to be the goal state. So it may be or it may not be. That's why every time whenever you are generating a possible solution, it's better to do the comparison of this possible newly obtained solution or newly obtained state with the goal state. Means whether it is your actual solution or not. If it is your actual solution, or if you have reached to the goal state, so better to stop your search process. Okay, better to stop the search process. That's why we are saying in step 3 we are saying that if a solution has been found, means whenever you do the comparison of this newly obtained state with the goal state, and if both are matching, then it means that you have reached to the goal point. That we are saying that the solution has been found. So in that case, it's just you perform the quit process. Why? Because you have reached to the goal point. But if it is not the case, Your goal state is somewhere else here. Still there are some other nodes to move. So if it is not the case, so what you have to do, you need to return to the step 1. So you have to generate a new possible state. So in that case, what happens? Your new possible state can be this one. Okay, so here also you are going to do the comparison whether this is a goal state or not. So in this case also, it is not going to be the goal state. So you are going to continue the search process. So up to what extent you are going to continue means whenever you reach to the goal state, then you are going to stop your search process. So in simple words, we can say the generate and the test algorithm is going to tell that first you generate a possible solution. Means try to change your state. Whenever a new state is obtained, you better to compare that newly obtained state with the goal state. If it is the goal state, then simply think that you have obtained the solution, you got the solution and stop the search process. So if it is not the case, you continue from the step 1. Okay, so this is all about the generate and test algorithm. Let us try to talk about the other things which are called as different regions in hill climbing. So hill climbing approach we know. So what is a problem in hill climbing means we need to identify the maximum path, maximum point we can say. Means whenever, for example, this is the hill we are having, we need to identify exactly this particular point. So this problem we can say that hill climbing problem also. So whenever you are trying to identify the highest peak point, the main peak point, then you are going to get some kind of obligations, or we can say some kind of problems. So we need to understand there are different properties that we need to understand while solving this kind of hill climbing problems. So those properties we can say, I am saying it as a regions, different regions in hill climbing. Why? Because if your problem is having only one particular hill, there is no problem. Okay, so the concept is very simple. Directly you can solve it. But whenever you are having some adjacent hills also, then you are going to get some other things. So what are those things? Are nothing but here the different regions in hill climbing. So what is the first one? Means it is the local maximum. The name itself is telling that it is a maximum, means the highest point, like this. But why we are calling it as local maximum means in a given state space. For example, if it is your given state space, in this given state space, along with one hill, there are some other adjacent hills also there. Okay, so if my point is, if my position is here, and what I can say that this is a local maximum. Why it is local maximum means the adjacent we are having one more hill, and that hill is far longer. We can say the height of this particular hill is very high when compared with the previous one. So in the given state space, for example, if your given state space is only this one, then we can say that this is the maximum, and we cannot mention it as local maximum or global maximum. Simply we are saying that it is a maximum. But what happened if you observe this particular diagram, here we are having multiple hills. So in this case, right, we are differentiating the maximums in two different ways. What is that? One, we are calling it as a local maximum. So if you observe, this particular point is considered as a local maximum. Why? Because for this one it is the highest one, but when you compare with the other hill, if you make the comparison with this particular hill, it is not the maximum. Why? Because the height of this particular hill is more than this one. So in the given state space, for example, if you see this one, this is going to be considered as the global maximum. Why? Because that is the highest peak point. So in simple words, we can say that local maximum is a state that is better than its neighbors. So when you compare with this particular hill, this one is a better one. But when you compare in the complete state space, that is not the better one. Okay, so we can say that it is a state that is better than its neighbors, but it is not better than some other states further away. Okay, right? So that is about the local maximum. And next it is global maximum. Global maximum means among the given state space. Okay, among the given state space, it is going to be the best possible state. This is because at this state, objective function has the highest value. Why? Because this peak point is going to be the highest one when compared with the other adjacent hills also. That's why we call them it as a global maximum. And sometimes you may get a region called as plateau or the flat local maximum. So what do you mean by flat local maximum? You can observe this particular thing. There is a flat surface, right? And even this flat surface, this is a flat, that's why we are using a word called as flat. And for this particular one, this is having the highest maximum. So that's why we are calling it as a local maximum. So this kind of regions also you may come across when solving these hill climbing problems. So if it is plateau or flat local maximum, it means that it is a flat region of the state space where neighboring states have the same value. So why? Because it is a flat surface. So you are going to get only the same value every time. Whenever there is a change, whenever there is an increase in the height, then only we are going to get different values. But in the flat local maximum, we are going to get the same value every time. And along with these three, we are going to see some other regions also. Like for example, you see ridge. Ridge, it is a region which is higher than its neighbors, but itself has a slope. So for example, this one, if we consider this particular point, it is having the slope. So we can treat them as a ridge. So even we can call it as it is a special kind of local maximum. Coming to the current state, the region of state space diagram where we are currently present during the search space. For example, in this diagram, this particular point we can call it our position is here. So we call them as a current state. Okay. Coming to the shoulder. So what is shoulder here? You can observe this particular point. So it is a plateau that has an uphill edge. Why? Because after this we are having some uphill. So we can say this kind of areas as the shoulders. So there are 6 different regions that we are going to come across when solving these hill climbing problems. So one is called as the local maximum, the global maximum, shoulder, flat local maximum, and also ridge. And the 6th one is the current state. So let us talk about the other important definition of this third module, which is called as non-monotonic reasoning and statistical reasoning. So we can say that non-monotonic reasoning, right? So in the reasoning, we are going to have 2 different kinds of reasonings, monotonic and non-monotonic. So let us try to work with the non-monotonic first. So in the non-monotonic reasoning, we are going to get some rules of inferences. It is going to have some rules of inferences which we are going to be used for extension. So why we need this extension of the rule of inferences means in order to get some additional information. For example, if you are feeling that the knowledge whatever we have used in the knowledge base is not appropriate to solve the problem, so we need to get some additional information. So in order to get some additional information, what we are doing, we are inferencing. Rule of inferences, we can say, where we are going to extract some additional knowledge. That additional knowledge will be added to the knowledge base, and which will help in the other sense, which is going to help us in order to solve the problems. So these systems preserve, however, the property of this one. What is that? Either it is going to be true, means non-monotonic reasonings are going to give the answers sometimes either as true, sometimes either as false, or sometimes not to be the either. So whenever you apply this non-monotonic reasonings, you are going to get the results are sometimes as true or false, or sometimes even both. It is going to be both, either it is true or it is going to be the false. But every time it's not a good practice to give the outputs as true or false. So there will be some AI problems where we need to represent our results in a different way. So in that case, we can say that non-monotonic reasoning is not going to help us. So there we need to work with the other kind of reasoning, which is called as statistical reasoning. For example, if the doctor says that the patient is suffering from some kind of illness, so simply yes or no will not make any sense sometimes. Why? Because the patient is not going to convince that simply if you give the answer yes or no, that will be a problem. So in that case, what happens, the doctor should be in a stage to explain the results in a more clear way. So in that case, what happens, we need to get some kind of value which is called as the probability. So how much probability is there means how much possibility, in simple understanding, in simple words we can understand how much possibility is there for true and how much possibility it is there for false. So in this case, instead of making use of these true or false things, we are going to use some kind of numerical values. Okay, we are going to make use of some numerical values. These numerical values, we are calling them as a probability. Means in simple words, we can say how much possibility is there to be true. How much possibility is there to be false. So in simple words, we can say that this statistical reasoning is the representation which is extended by using some numerical measures. So in order to overcome this uncertainty, why? Because simply saying yes or no is giving some kind of uncertainty only. So to make this uncertainty to certain, we are making use of some numerical measures. What is that numerical measures? Is nothing but here the probability. For example, if I give a particular image to a neural network and if I ask to perform the classification, so it may classify it as a cat. But simply saying that it is a cat image, I cannot get convinced. So in that case, this statistical reasoning is going to help us. So how much possibility is there for this image to be a cat image? So I can say that 85% possibility is there. So what this 85% is nothing but the probability. Means probability to prove that this image belongs to cat. Like that it is going to be. And so we will try to understand more things about this probability in the coming sessions, definitely. Coming to the other kind of reasoning system, which is called as conventional reasoning systems. So even we can say these conventional reasoning systems as the first order predicate logic systems. So why these systems are used? In order means they are designed in order to work with information which are having three different properties. The first property is it is going to be complete with respect to the domain of interest. Means to which domain the problem statement belongs to. Based on that, it is going to be the complete one. The system is going to be complete. So what do you mean by this complete? So in other words, we will try to understand. So all the facts that are necessary to solve a problem are present in the system, or otherwise you can derive the new things from the existing one. So first order predicate logic is going to help us in order to provide the required facts to solve a particular problem, or it will allow us to extract new things from the existing one. And even we can say that the other property. So what is the first property? It is going to be the complete one. Means whatever the knowledge you require to solve a problem, all that knowledge is available in the system. Okay. So and also the second property, we can say that it is consistent. It is consistent in the sense it will never change. And the third property is the only way we can change. So what makes us to change it means by adding the new facts. So in this case, we are going to get some kind of problem. What is that? For example, think that before adding these new facts, if any of the statement or any of the conclusion has proven to be true already, means there is one conclusion which is already proved as true. So whenever you are adding new facts, what happened? There is a possibility of, means there is a chance that this conclusion is going to get changed. Means previously it is true. Now whenever you are adding new information, it may become false. Okay, but when we are talking about the monotonicity in the sense, even if you are adding the new facts or new information to the existing knowledge base, it is not going to reflect on the things. What is means the conclusion before it has proved to be true. Means even if you are adding the additional information to this conclusion, still this conclusion is going to be true only, but it is not going to be false. That's why we are saying that it is consistent. It will never change even if you are adding the new things to the existing one. Okay. So unfortunately, if any of these properties is not satisfied, for example, if any of these properties, what is that? Adding of new informations. Okay, if it is not satisfied, what happens? These reasoning systems are going to be adequate. So that's why we can say that the conventional reasoning systems, if they are proving to be false after adding some additional information which has already proved to be true earlier, so we can say that these systems are not the perfect systems. So these reasoning systems are not helpful for us. They are going to be inadequate. So in that case, what happens? We need to look for the alternative reasoning systems. So which is going to be the non-monotonic reasoning systems. So this is all about the today's session. So in order to prepare this content, the references I have made use of are these two, and hope you understood some of the definitions and terminologies related to this module 3, and we will come up with the other definitions and terminologies in the next section. Till now, thank you.
Like, share and subscribe. Hit the bell icon for more updates.